day, we often thought that the power of a light bulb was the number of watts. Well, what would power of a light bulb be measured in? It really should not be measured in electricity. It should be measured in how much light it gives off. Properly, a light bulb should be measured in lumens, how much light it gives off. In the advent of the fluorescent light bulb, we find that there's far fewer watts that generates far more lumens. You get a lot more bang for your buck when you're buying fluorescent. My name is Paul Pasolka, Ivy Masters Learning Center and ivymasters.com. Today we're going to look at Test 5, Section 4, number 31, which is a relationship between another two power sources which are more directly correlated. 31 reads, horsepower and watts are the unit of measure of power. They're directly proportional such that 5 horsepower is equal to 3,730 watts. How much power in watts is equal to 2 horsepower? So whenever you have 3 different numbers, what you should do is check. Do 2 of them have a relationship with each other? And does the other one have a relationship with what's being asked about? If it fits that criteria, then what you want to do is set up a proportion. So the 2 of these have a relationship with, 2 of them are in the same units, horsepower and horsepower. And the other number you're given is watts, and the question is asking how many watts. So you know you can set up a proportion. Now sometimes proportions confuse students because there's actually 4 proper ways to set up a proportion. I'm going to first set it up the most common way. Most students will say 5, and I'll put a little h here, that's not a variable, that's just so that you see the relationship here. 5 horsepower is 3,730 watts, put a little W there. And that's going to be equal to, and then you've got to say, hey, what does the number 2 have a relationship with? It actually has a relationship with horsepower. So the 2 should go on top. I'll put a little h there to show that they have a relationship. And then I'm going to put my x down here. It's x what? It's x watts. I'm going to ignore the h's and the w's because, again, they're just there to show the relationship. Now, when you set up a proportion, you just got to make sure you have that relationship. Notice the tops have a relationship with each other, 5 horsepower, 2 horsepower. They're both horsepower. The bottoms have a relationship, they're both watts. On the left, the tops and bottoms have a relationship with each other. You have 5 horsepower equals 3,730 watts. And on the right, those have a relationship with each other. It's 2 horsepower equals how many watts? So for that reason, we would say the product of the means equals the product of the extremes. So what I would do at this point is I'd cross multiply and set equal. And so I get 5x equals, and it's going to be 2 times 3,730, which is going to give me 7,460. And then to finish, I'd divide by 5, and find that x equals, and at this point I'm just going to cheat using my super high-tech built-in calculator over here, and we've got 7,460 divided by 5, and we've got 1492. It was a very good year. Well, that's when Columbus discovered, but if you so 1492 is your answer. But if you saw my other video, you'd see that Columbus wasn't always so nice. All right, the other ways you could set this up properly is, notice if I flipped these fractions, I could say 3,730 watts is equal to 5 horsepower, and then I could say how many watts is equal to 2 horsepower. Once again, notice what I do. When I cross multiply and set equal, I get the same thing. I get 5x equals 2 times 3,730. There's 2 more ways to set this up properly. Let's say these are your fractions, you have your equal in the middle. You could say 5 horsepower equals 3,730 watts, and then you could say 2 horsepower equals how many watts? And again, you cross multiply and set equal, you get 5x equals 2 times 3,730. Last way you could set it up is what I just did, but flipped. You could say, actually, let me work off the original, which you can, well, actually, let's say 5 equals x over 3,730. Now, how do I know that all 4 of these setups are right? Because This one over here, you still have horsepowers on the left, and you still have watts on the top, you still have horsepower on the bottom, and you still have 5 horsepower equals 3,730 watts, and you still have X watts equals 2 horsepower. Okay. How does the next ratio have a relationship? Well, what we've got is we've got horsepower here, and we've got watts here. And then up top, we've got that 5 horsepower equals 3,730 watts, and down below we've got 2 horsepower equals how many watts? How do we know we're set up correctly here? On the left, once again, we've got horsepower. On the right, once again, we've got watts. Up top, we've got 2 horsepower equaling X watts, and on the bottom we've got 5 horsepower equaling 3,730 watts. So once again, you cross multiply and set equal, you find 5x equals 2 times 3,730, and then you get your answer, which once again is 1,492. Thank you for joining us today. If you like this video, click like. You can share it with someone who has trouble setting up, recognizing, and then setting up proportions. If there's any question you'd like to see from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.